So, question 2C, greatest common factor, same idea. We have 4a squared times b squared minus 6a, and that a is technically to the power of 1, okay, and b cubed. So, exact same thing as we did before. I'm going to look at my coefficients. I have 4 and negative 6. Like I said in the 2a, you can take out a negative number, or you can take out a positive number. If you did it either way, I'm still going to give you the mark, okay? Do whatever you feel most comfortable with. So a common factor for 4 and 6 is 2. So that means I'm going to divide both of those terms by 2. So my next line will start with equals 2. Make sure you guys keep this 2 outside of the brackets. I'm going to say maybe half of you were taking out the right common factor, but all you were doing was leaving me the answer inside the brackets, and you weren't giving me this 2, or this 4, or 4m, or whatever the common factor was. So if these were out of 2, I could only give you 1 mark. I knew you took out the right common factor, but you didn't write it outside the brackets. It's no longer the same number. It's imperative you guys keep it there, okay? Get rid of those lines. So when I divided it by 2, 4 by 2 is 2. I'm going to keep my a squared and b squared. We'll deal with that after. Negative 6 by 2 is negative 3. A technically to the power of 1, but we need to write it in. Okay, so I've taken out a common factor for the coefficients. Next I'm going to work with our a's. I have a squared, so that means I have 2 a's, and a to the power of 1. Take whatever you have least of out. So because I only have 1 a, I'm going to take 1a out. You're going to see another example of that when we do b. So I still have my 2. This time, though, I'm taking an a out of both. That a comes to the outside. I'm still left with 2. Now, because I had a squared, when I take 1a out, I'm going to take away one of those a's, so I'm only left with 1. b squared minus, here I have 3. Here we only have 1a, a to the power of 1. When I take a to the power of 1 out of there, it's going to leave me with nothing. Technically leaves me with the number 1, but let's assume nothing's there, okay? So I don't have to write any more a's in. All the a's are gone, and I'm left with b cubed. So now I've taken a 2 to the outside, and I've taken an a to the outside. Last term I'm going to deal with, the b's. I have b squared and b cubed. So like I said before, take whatever we have least of. So I have 2 b's in the first example and 3 b's in the second. Well, because I have 2 of them, that's the lesser of the 2 numbers, I'm going to take 2 b's out. So when I go to the outside of our equation again, I'm going to be dividing by b squared. That means 2 of our b's here. Both of those terms. So I take b squared to the outside. I'm then left with 2a b squared divided by b squared. Just leaves me 1. So assume all those b's are gone. 3. I had b cubed divided by b squared. 3 minus 2. That's how you think of it. 3 minus 2 is 1. So I just have 1b left. Our final answer is 2ab squared. 2a minus 3b. Now, I took many steps to solve this. Many of you did this in one. That's fine. You don't have to show all of these, okay? Only reason I did it is so you guys can understand how you can separate it, okay? Okay, so this question says to factor. We've learned quite a few ways of factoring. We have common factoring, we have our special cases, and we had our quadratic factoring. We end up with 2 brackets. So I look at this. The very first type of factoring you guys want to deal with is common factoring. Always try to take a common factor out first. It'll make all other types of factoring easy if you're able to do it after. So common factoring is the exact same stuff we did in question 2 on the first page. So you take a common factor out of these. I'm going to look at the coefficients, 2 and 5. Common factor of 2 and 5. Only one there is the number 1, and there's no point in taking the number 1 out because it changes nothing. So think of it as there is no common factor, okay? So for my coefficients, my numbers, I couldn't take anything out. But let's look at my variables. I have x squared and an x. Well, because I have at least a pair of variables, I can take an x out. Technically, this is to the power of 1. So think of it as if I'm taking out x1 from both of these. So our next line on the outside, we have x. When I divide 2x squared by x, I'm left with 2x. And when I divide 5x by x, I'm only left with 5. Okay? Very similar to what we had before. I divided by an x. I divided by an x. That's my final answer. X times 2x plus 5. Now, after I did my common factoring, I could have looked at the 2x plus 5, and in my head, I quickly looked at our other styles of factoring. Is it a special case? No. Can we do our quadratic factoring, where I get two numbers? No, doesn't hold up to either of those. So that's as far as I can go. It's a pretty straightforward question. A good way to tell if there's a lot of steps is take a look on what I've put the question out of. This one's only out of 1, probably only 1 step to it. Okay? Maybe 2 if you extend it. So, that's a good way to tell how far you need to go. Next question. 1b. 6q2 minus 3q. So, many of you guys, once I started putting in different variables, q, m, I used p and y, you guys still wrote your answers in x. I didn't take any marks off, but it's not technically right. If the variable is called q, you have to factor q. You don't factor an x out of it, okay? So I want you guys to try to get used to that. If I've written it as a q, you can imagine it's an x. You can change it throughout the whole question, but when you give me a final answer, all the variables, they need to be in the form of q, okay? I didn't take any marks off, but try to do that for the test. So same idea as above. Look at the coefficients, 6 and negative 3. I can take 3 out of both. So I take my 3 out. This becomes 2q squared minus, now technically that's a 1. I don't need to write a 1 in. I can just leave it as q. I've dealt with the coefficients. Let's look at the q's. I can take at least 1 q out of there. So this becomes 3. The q I take to the outside. 2q minus. So this is where we get into a bit of trouble. Some of you guys would have got. I had only a q left, and I divided by q. Anyone know what number would be left over? Q divided by q, Connor? 1, that's right. I'm only left with a 1. Okay? So, because I took that q away, doesn't mean there's a 0. Q divided by q is 1. I'm left with just 1 at the end. 3q, brackets 2q minus 1. That's our factored form. And C, we've done one very similar to this. Take a look at it. The common factors here are actually in brackets. M plus 1, M plus 1. It's in both of those. So I'm going to take M plus 1 to the outside, and in my normal brackets, just like we do the same steps before, M and negative 2, M and negative 2. Okay? Those are my common factors. That one's straightforward. We've done it just on the previous page. Okay, 2c, x squared plus 7x plus 12. All right, this type of factoring, like I said, first thing we always look for is a common factor. I look at all the coefficients, 1, 7, 12. The only common factor in there is 1, okay? So I can't take anything out in terms of numbers. Now I look at my variables, x squared, x, and nothing. Once again, that means there's no common factor. I can't take a variable out. So I can't common factor this question at all. Now I look to quadratic factoring. So remember we did this before, where we're looking for a number that multiplies to our 12 and is going to add to our 7. So we need two numbers. Multiply to 12, and the same two numbers are going to add to 7. Who can help me out? Lewis. 4 and 3. Now because this is positive 12, we can use positive 4, positive 3, and does positive 4 plus positive 3 equal positive 7? Yep, they work. Great. So I can go right to my last step. I make my two brackets. This x squared, consider it as if I'm splitting it, okay? One of them in this bracket, one of them in this bracket. Then I take the numbers I decided multiplied to 12 and added to 7, so my 4 and my 3, and I just put them in the second space. So I had positive 4 and positive 3. That's all there is to that question. X plus 4, x plus 3. I factored that. Okay, since you guys are okay with that, I'm going to move quickly through this one. Y squared minus y8 plus 15. Same idea. They need to multiply my two numbers to positive 15. And they need to add to negative 8. Okay? Positive 15, negative 8. Luckily, from doing this, I know that negative 5 times negative 3 equals positive 15 when I multiply, and negative 5 plus negative 3 equal negative 8. Same idea. Split my y. Minus 5, minus 3. It's my final answer to 2D. Y, bracket y minus 5, and bracket y minus 3. 2E. Okay. 2E is a little different. Remember, we always want to do common factoring first, if we can. So, I'm going to try to common factor this. If I look at the coefficients, 2, negative 2, and 40, I can take the number 2 out of this. When I take 2 to the outside, I'm left with p squared minus p minus 20. So that 2 is on the outside. You have to keep that 2 there. Once I've done that, I take a look at this. I still need two numbers that are going to multiply to negative 20. And they're going to add to negative 1. Those numbers are negative 5 and positive 4. Negative times a positive is a negative. 4 times 5 is 20. Negative 5 plus positive 4 is going to give me negative 1. So, I have my two sets of brackets. Split the p to both. Negative 5 and positive 4. So my answer was 2, bracket p minus 5 and bracket p plus 4. So, technically, I look for the coefficients. I look for a common factor between all of these. I can take 2 out of all of these. When I take 2 out, I get 2x squared minus 7x plus 6. Okay? So I've taken that 2 out. Now I have to do a factoring where the number in front of the x is not 1. So this was our Thursday's work. Okay? Sorry, we'll erase that. Remember, when we do this, the style we're trying is we take factors of the first number, so 2 and 1, and all the factors of the last number, so 1 and 6 and 2 and 3. Think of them as columns. And they need to add up to our negative 7. So I'm looking for two numbers. So I can start doing trial and error. I know that this is the column I'm going to use, 2 and 1. For the first question, I'm going to multiply across. 2 times 1, 1 times 6. That's going to give me 2 and 6. There's no combination of 2 and 6 that's going to get me to negative 7. Oh, I just want to take a look at this. Oh, man. So we have our answers. I keep my 2 on the outside. I go to make my brackets. I attach 2x and x. And my factors are negative 2. And because I multiplied 2 by negative 2, they have to go in opposite brackets. So the negative 2 does not go in the same bracket as the 2x. And same with the negative 3.